Good evening and welcome back. This is the third video for Galvanic Cell in which we are discussing the reactions in the galvanic cell. In the previous two videos we have talked about construction and working of a galvanic cell. Now, as we have seen in the previous two videos, which you can refer to in the playlist, in the anode of the galvanic cell, which is the left terminal of the galvanic cell, we have the zinc which is losing 2 electrons to become zinc 2 positive plus 2 electrons. This we had seen. I'll just take you back to that slide here. In the anode, the zinc lost 2 electrons to convert to zinc 2 positive, and those 2 electrons then transferred to the cathode. So at the cathode, the 2 electrons were attracted to the copper 2 positive present in the electrolyte of copper sulfate, and they neutralized copper 2 positive to copper solid. Okay. These are the two major reactions which are happening in the galvanic cell. At the anode, the left terminal, zinc is losing 2 electrons to become zinc 2 positive. These 2 electrons travel by the wires and they reach the cathode, which is the the right terminal, and they reduce copper 2 positive to copper solid. Now, in the first case of the anode, the electrons are lost, and loss of electrons is oxidation. So the anode is the side of oxidation. Whereas in the cathode, the copper 2 positive gained 2 electrons to become copper solid. So this is the site of reduction, because oxidation is called your loss of electrons and reduction is the gain of electrons. So at the anode I had oxidation, whereas in the cathode I had reduction. Okay, this brought about the redox reaction, and this generated the current as we had discussed in the previous video of the working. Okay, now if we combine these two reactions together, because they are happening simultaneously in redox reaction, oxidation and reduction always happen simultaneously. So I have to get an equation in which I can combine these two together. So I can write the net reaction or the main reaction which is happening here in the galvanic cell is combining 1 and 2. So what I can get? Zinc, so just see, plus copper 2 positive, because we'll combine the left hand side together and the right hand side together. Left hand side is zinc and copper 2 positive plus 2 electrons. So I'll write plus 2 electrons. And in the right hand side I can get what is zinc 2 positive plus copper metal plus 2 electrons. Okay, so for net reaction, combine the left hand side, which is this and this, to the right hand side, which is this and this. Now electrons are same on both the sides, so they get cancelled. When we have same electrons on both the sides, they get cancelled, and we get the final value as zinc plus copper 2 positive gives me zinc 2 positive plus copper solid. This is also zinc solid. Okay, this is the complete reaction in the galvanic cell. Now, for this reaction, if we have to represent this reaction, how do we do that? This is again very important, cell representation of a galvanic cell. What we do is we just write it in the same order, okay, but the way we do it is a bit different. For cell representation, I will first write what has happened in the anode. In the anode, zinc converted to zinc 2 positive, whereas, and then I will write what is happening in the cathode. In the cathode, copper 2 positive turned to copper. In between these two, I will be drawing single lines which represent the phase boundary. Now what is the phase boundary? Zinc was in your solid metal, whereas zinc 2 positive was in the electrolyte, and here copper 2 positive was in the electrolyte, whereas copper was in solid. That's the phase. Okay, and between zinc and copper I will be drawing two lines here, and these two lines actually represent the salt bridge which was there in the galvanic cell. Okay, the salt bridge which actually made the functions possible of the galvanic cell. I would write it like this. So concluding, what is the way we write the cell representation of a galvanic cell? Zinc solid was in with contact of the electrolyte, which was zinc 2 positive, with the salt bridge, copper 2 positive changed to copper. So only the reactions which are happening, the half reactions, I would write and separate them with a double dash for the salt bridge. So here the double dash represents the salt bridge, Single dash represents the phase boundary, which I just told you about. Okay. One more thing is missing in this cell representation. It is that we had taken this reaction in 1 molar concentrations of the electrolyte, because I told you galvanic cell will react in standard conditions. Otherwise, the products will change. You will learn about this in the topic Nernst equation class 12, okay, of electrochemistry. There you will understand why we are taking it in standard conditions. So I will write this as 1 molar here also, and I will write 1 molar here also, because these two positives were in the electrolyte. So electrolyte was taken as 1 molar, so it's very important to write 1 molar, which indicates your standard conditions. Okay, so this is indicating my standard conditions. Okay, so this was your cell representation. There is one more quantity which we have to know for galvanic cell, is called your N value of a cell. Now N here stands for number of cancelled electrons. How many electrons got cancelled in the redox reaction or transferred? Instead of cancelled, we can also call transferred from one terminal to another. And as you have seen in the net equation here, that I cancelled or transferred 2 electrons in this equation. So the N value for this equation becomes 2. Again, N value is used directly in class 12 in the topic of Nernst equation, from which you will understand this concept more. So how many electrons you are transferring or simply cancelling in the equation is your N value. Lastly, to conclude, in the galvanic cell, so in the galvanic cell, I have 2 terminals, the anode I'm sorry, there is some error happening, and I have the cathode as well. Okay, the cathode here. The anode is the left terminal, the cathode is the right terminal. Okay, in anode I have oxidation, in cathode I have reduction. Okay, that means if I have oxidation, that means the loss of electrons here in the anode, it becomes your negative terminal, and cathode is your positive terminal. This is also a universal convention. We generally use the anode as a negative terminal and cathode as a positive terminal. In anode, as there was loss of electrons, it means that the anode, as there were oxidation is indicated by loss of electrons. So in the anode we had loss of electrons as well. Okay, whereas in the cathode we had reduction, and reduction is opposite of oxidation, which means there was a gain of electrons. The loss of electrons would be equal to the gain of electrons, and that will be your N value as well. Number of electrons would give you your N value for the cell as well, is the conclusion for galvanic cell, which in turn is a device which converts chemical energy of a indirect redox reaction split into an anode, the negative, and cathode, the positive terminal, for generation of electricity. Okay, and hence it becomes an equally important topic for the concept of electrochemistry, class 12, and redox reaction class 11. So in case you have not watched the previous 2 videos, please watch them in the playlist, and soon I will be coming up with a video on standard reduction potentials from galvanic cell and numericals based on galvanic cell. So stay tuned, we'll be back with questions and the concept of standard reduction potential, which is very, very important and gives you the most important questions from galvanic cell, come from there only. Okay, so with this we close the class. Thank you, and please like, share and subscribe the channel. In case if you have any doubt or want me to come up with any specific topic, please do write in the comment section. It's all yours. Thank you.